All right, let's look at this one more time and see if we can figure out what's going on. Okay, so it seems like it's not taking into consideration the actual indentation of each node. Let's try computing that from the tree. So what we can do is basically walk from our current node through the parents until we hit the root and count how many times we have to indent that. So we can do maybe a simple, if the node isn't the root, then the node becomes its parent and we increment the counter and then we'll just check it again. So let's do that here at the top before our label, before the label. We can do auto node equals tree. Then we can say auto root equals tree.getRoot. Right, we're making a local copy because we don't want to actually change our actual tree. And then we're going to need a counter, so auto indent equals 0. And we will do while node does not equal root, node equals node.getParent. And then we'll update our incrementer. Indent. Oh, let me spell that right. All right, so this algo is now in place, this algorithm right here. So now we can just multiply the tree view's indent size bar by our indent amount and add it to our length. So we've got our size here plus. So now we can just do indent times get owner view, get indent size. All right, let's try it. All right, cool, this is much better. It's not capturing the first node for some reason, and that's because, let's see. Oh, that's because the first node is the root, and therefore it's not going to change this from 0 to, it's not going to add an indentation for that. So let's try making it a 1, and let's run this again. Okay, cool, that's a lot better. So we get our full name. This is extending all the way across to the end of it. It looks like there's like a little bit extra for some reason. This one that's indented a lot more seems to have a lot of extra space compared to the others. So it's close, it's not perfected. Okay, so how about we say if for our indent, let's start it with, let's do if node equals the root, then we'll say start with 1, otherwise start with 0. All right, let's try this again. Okay, that's better. It's still not totally right. All right, you can see there's like a big chunk here. There's not a big gap here. There's not a big gap there. So let's just ditch this indent altogether. Okay, nope. We have ellipses. That's not what we want. All right, let's just ditch. Let's ditch this indent altogether and just make it 1. Whoops! What just happened? There we go. All right. That's the correct item width right there, which means we don't need any of this indent stuff, so we can just comment this out. Okay, we tried it out. It was worth it. You know, worth investigating. Okay, so this is cool. This right here, what we currently have. This works, but what we want is to have every row have the same right edge. We want this one to extend all the way to here. Same for this one. That's what we want to have happen. So we have to find the longest name for the tree. So let's just get rid of this old approach altogether. All this stuff with the label. Let's just get rid of that. Let's write a function that will give us the longest name in the tree. This function is going to scan all of the nodes in the tree, so we need to pass it. We need to pass in our tree root, and we need the root item's height and the indent size of the tree view. Okay, so based on these requirements, this function should take a value tree that it can find the root of, and then a reference to the tree view. So let's call it get longest name, and we'll just put that right at the top of our this guy right here. And we can get rid of all this stuff too. We'll just say auto longest equals get longest name, and we'll pass it tree.getRoot and our owner view. I'm not sure what it's going to return, but we're just going to restore the result in a variable named longest for right now. So we want to know how long the longest name is, as that is what I was returning before. Right? This is what I was returning here. I was returning the length of that item. But I want to print out what that longest thing is, so we'll use our make name thing again. So we will do, let's see. Let's get started on this thing. We'll put that right here. We'll go, let's see. What's the best way to approach this? Okay, we want to know how long the name is, because I was returning that as an integer. But I also want to know, I want to print out what the longest thing is. So it sounds like we have an idea of what our return type should contain. It should contain the length and also the item itself, or a string of it of some kind. So let's just wrap it in an std pair. Std pair, we'll say the integer and value tree. That's what we'll return. So get longest name. This will just be a regular free function. We want to pass it a value tree, and then a tree view reference TV. Like that. All right, let's add our indenter so we can see which node is currently being processed. Just grab one from here, indenter, and then we'll just do debug indenter, get longest name, tree, and then make name. This goes here, closing parentheses, so it looks like something. All right, next let's make our winner, whichever one is the longest. And now we can figure out our name stuff. So we can use this part right here. String name equals this, and then if it's the right one, or if it has kids, append the name to it. And let's use a static label this time, so we don't have to keep recreating the label each time this function is called, because this function gets called for every single every TaskQueue item when the tree is refreshed. So we'll just make it a static guy right there. And now we'll do the same size param thing that we did before. Let's see. Auto size equals get item height. So we will do auto size equals our tree view dot. We want the root item like that, because remember we're trying to call this member function, and we'll just call, all these nodes have the same height. So we'll just the root item is the one that we'll just interact with. Then we can set our size. Previously, we returned the length, and instead we're going to store it in the pair as the first element. So this is the same calculation as before. That's this thing right here, label.getFont, plus this stuff. We will do winner.first equals this thing, and we can get rid of our indent, and we're not using getOwnerView, we are using TV dot. And therefore our winner.second is the tree that was passed in. So now we need to compare against the other nodes. And remember, we are passing the tree root in, so we need to go through all of the child nodes and check their lengths and compare. If the child length is greater than the passed in tree's length, then that child becomes the winner, and we can then return the winner. So we're going to use a for loop for this. The easiest thing to do is just to call this get longest name function with the child node for each tree, and it's going to recurse the whole tree like we need, and it's going to check all of the children for the longest name. So we will do for int I equals 0, I is less than tree.getNumChildren plus I, and now we can just loop through the children. Auto child equals tree.getChild. We can do auto result equals get longest name child, pass in our tree view. If result dot first is greater than winner dot first, winner equals result. Okay, so the very first time this is called, this is the tree root. The tree root is the current winner, and then when we recurse through all the children, the result is the winner of that recursion. And if the winner of that is greater than our tree root the very first time, then our new winner becomes whichever child has the actual longest name. Right. And then we just need to return winner. Okay, now that we have a winner and we know that longest is an std pair, now we can do debug longest. Oops, let's print it out. Longest. And print out the name. Make name longest dot second. Now we can return longest dot first. All right, let's run it. Okay, so they are all the same length, but they are not having the same right edge. Oh boy. We have a leak in OSX typeface. That's really weird. Another one. Class typeface. Oh boy. That must be in relation to the that must be in relation to this static label get font thing.